Okay, so we're going to look at how path planning is calculated. And this planner could be used in a robot, and it allows a machine to get from one place to another. Okay, and the idea of all of this is the world of where the robot is going to be running around, so is divided into little square blocks. And we could say that each of these square blocks is, for example, 1 meter by 1 meter square. So the whole world that the robot knows is split into 1 meter squared blocks. And the idea is that we need to solve a path to allow the robot to get from its starting position to its goal position. So this could be in a large room, or it could be a room with walls. So let's put some obstacles in here representing walls. And some other obstacles, maybe a chair. And the plan is that the robot has to get from the starting position to the goal position. So let's make this quite hard for the robot. So let's say that the goal position is over here. Okay, so in the robot's memory, we have this 5 by 5 grid. This is the robot's world, and it really needs to get from its starting position down to the goal. But which way does it go? Does it go this way? Obviously it's a dead end. So we can see, because we're quite clever, that it needs to take a path like this. But how do we do that? Well, if you've put the plan, the map, into the computer, perhaps as an array of data, and each of these squares can hold a number. And what we'll do is we'll use a set of numbers to represent the path that the robot's going to take. So let's say that 1 is our goal position. And let's say a high number, let's just put 255, it's a high number, is going to be an obstacle. Okay. And initially the array is filled with all 0 values. It's initialized to 0 values. Everything of this is zeros. And then what the planner does is it puts values in of the places that it knows. For example, the goal is position 1. The obstacles are values 255. Okay, so how does the robot follow this path and find its way to the goal? Well, what we're going to do is we're going to do some path planning, and we're going to put numbers in these empty 0 squares. So what we do is, with our planner, we run a routine that looks for the number 1. When it finds the number 1, here we go, we look to the above position, to the right, below, and to the left, and we put the next higher number in than 1. So above, the next higher number is 2. To the right, okay, that's off the screen, so we don't bother worrying about these two. And to the left, we've got a number 2. And then what we do is we run a routine that looks for the number 2s and adds the next higher number. So we find a 2 here, so we look above, so we put a 3. The next number here, we find a 3. And it only puts values in, I should have said, as long as it's a 0. So if it's a 255, we don't put a value in. Okay, so everything that's 0 we need to fill up with a number. Then we look for the 3s and put the next higher number in. So we've got 4. Then we look for the 4s and put the next higher number in, a 5. We look for the 5s, put the next higher number in, we've got 6. Look for the 6s and everything that's neighbouring, put the next higher number in, 7. Look for the 7s, put the next higher number in, 8. Look for the 8s and put the next higher number in. We've got 9 here and 9 here. Look for the 9s, we've got a 10 and a 10. Look for the 10s, we've got an 11 and an 11 there. Look for the 11s and we have 12, 12. Look for the 12s, we've got 13. Okay, now to solve the path, all you do is you move into the square, which is a lower number or equal. So which way does this robot go? Does it go up, to the right, down, or to the left? Well, it goes up to the 8. It's at the 8, which way does it go? Not the 9, it goes to the 7. So at the 7, it goes to the next number, 6. So at the 6, it goes to the 5. At the 5, it goes to the 4. Now at this point, it can either go this way to the 3, or this way to the 3. It doesn't really matter. It's just down to the algorithm which one it looks at. It's the same result. So let's go this way. 3 to the 2, 2 to the 1, and goal. So if it's a robot, it needs to know how to get from one square, and it can either move up, down, left, right, and now it can find out which square it needs to go to.